Two tiny CMEs on Soho the last day. Imagine getting slapped in the face at half a mile an hour. Not going to hurt or knock you down, right? Same thing here. The people freaking out over small solar wind perturbations the last few weeks, and there does appear to be lots of them, are going to have an absolute heart attack when real CMEs come back. I cannot wait to spend time in these shows doing in-depth space weather analysis, but it requires relevant space weather to do so, which this is not, especially because both are going to miss Earth. Well, folks, the cold event is ongoing in the United States, both cold and snow records. Record snow in Colorado versus record cold in Canada. Neither one is a joke or something fun to experience. Let's jump right into cosmology and particle physics because some good articles are out about a new experiment that will change science as much as that expansion map revelation we went over in last night's video. Protons and antiprotons, positrons and electrons, quarks and antiquarks. Turns out, mirror antiparticles are not exact mirrors, at least in the leptonic neutrinos and electrons. And can you imagine the implications? Virtually everything about matter is going to have to be reconsidered. They were thought to be exactly the same particle, just opposite charge. And that goes double when it comes to applying those beliefs at the great cosmic scales, where tiny little mistakes can be greatly, greatly amplified. Up next, folks, we're looking at the changing orbit of S2, one of the closest stars to the center of the galaxy. And it turns out that it's got some nice apsidal motion over there, and in a geometric pattern with which I'm sure many of you are familiar. What science is most clamoring about with the story is the fact that relativity predicted this motion, while Newton's gravity does not. The geometry can be described as a precessing forward within the motion plane with each orbit. Folks, there are 3 galactic disk articles today, representing a surge of interest in the current sheet for some reason, star trackers, then velocity maps, and most importantly, the look at the closest 3,000 light years to pick out critical structure nearby. Now, when looking at just the closest regions here, you're not going to see all of the ripples. You should be able to see the waviness of the curve presenting as an angled line right in front of you. Maybe it would start to be more undulating as you look to the edges, the far sides, and caught it wrapping around the galactic circle. Well, folks, that's exactly what this angled return is here. We'll be moving from the north magnetic sector in the galaxy to the south, and also notice how, at the edges over on the sides where it would be wrapping around, we do notice that waviness begin to show up in the return again. This is, of course, vastly important because we believe the sun crosses that sheet every 12,000 years, bringing about a tremendous upheaval. And of course, we've been trying to track the progress of the ongoing magnetic reversal at Earth. And since they've stopped giving us data on how much the field has decreased, we'll have to use something like ozone, which just hit a record low mark up in the Arctic. Now the question is whether their simple meteorological explanation is warranted, or if this is telling us more than it seems. They're blaming the strongest polar vortex on record for creating the conditions for the ozone hole to form up north, but we must remember that as Earth's magnetic field is weakening, more solar protons will destroy the ozone and also force that positive strong vortex, which does create those same conditions. Now, while the low solar activity we've had of late would normally force a weak polar vortex, that's not the case if we lose Earth's magnetic shield. Enough energy would get in. And I would argue that we need to see evidence of this ozone hole being very short-lived, because if it's not, it could mean our field loss has accelerated. It's also worth noting that the last 2 times we had major Arctic ozone holes, it was at the beginning of sunspot cycles, just like we're in now, 1997 and 2011. Definitely going to be keeping eyes on this going forward, as it's one of the only indicators we're going to have of the field status, other than waiting for CME impacts to see how disruptive they are compared to expectations.